In this video, I'll be talking about some around about 10 points regarding the introduction to nanotechnology. And to start with the definition of nanotechnology, and this nanotechnology is a field of science and engineering that deals with the manipulation and control of matter at the nanoscale. And this nanoscale ranges between 1 to 100 nanometers. And what's 1 nanometer? 1 nanometer is 1 billionth of a meter. That means if we divide 1 meter into a billion parts, the billionth part of that 1 meter will be the size of 1 nanometer. So the next point is what is the importance of this scale? There are other scales like micrometer, picometer, and some other scales. There's a range of scales out there. What's so important about this scale? At this scale, at nanoscale, materials exhibit unique properties and behaviors distinct from their bulk counterparts. So, if I have a bulk of gold, if I take this gold to the nanoscale, its properties will be different than that of bulk. So this is why the nanoscale is making nanotechnology a promising avenue for developing innovative applications. The next important point is the interdisciplinary nature of nanotechnology. So nanotechnology is we cannot assign this subject to a single domain of science. It is certainly an interdisciplinary science. Not only science, I should incorporate social science as well in it. So this nanotechnology is highly interdisciplinary, drawing principles from physics, chemistry, biology, material science, engineering, and so many more fields are working together in the field of nanotechnology. And now let me give the historical background of this nanotechnology. The concept of nanotechnology, it can be traced back to a talk that was given by Richard Feynman, and he was a physicist. And in 1959, he delivered a lecture, and in his lecture, he came up with some imaginary kind of things that could be possible at the scale which is very very small in comparison to the bulk matter. So the credit goes to this man because he was able to predict that there are many possibilities that can be governed at some smaller levels, at some smaller scales. Now, there are two important techniques in nanotechnology which are used to prepare the samples, which are nano in their views. And this nanotechnology employs both bottom up and top down. Now, what is this bottom up? Bottom up simply it's the building of nanomaterial by making an interaction between the atoms and molecules. And when we talk about the top down, in case of top down, the bulk matter is broken down to the very very small size. So these both techniques are utilized to prepare the materials, to prepare nanomaterials. So this nanotechnology employs both. It employs both bottom-up methods, where materials are built by atom by atom, and top-down methods where larger structures are scaled down to the nanoscale. Now, nanomaterials. So certainly the materials of whose domains fall within the range of this nanoscale. These materials form nanomaterials, and this nanotechnology has led to the creation of novel nanomaterials. With tailored properties such as nanoparticles, nanotubes, nanowires, nanocomposites, graphene, carbon nanotubes. To talk about some of the important applications of nanotechnology, nanotechnology finds applications in various fields, including electronics, medicine, energy, environmental recommendations, manufacturing, and it does offer a long range of solutions to the global problems. The next important point is the nanomedicine. So in medicine, the nanotechnology, it's doing miles. It's doing a lot of advantageous approach when the things are done in positive direction. So this nanotechnology enables targeted drug delivery. The drug can be delivered to the targets without actually causing the surgical things that are done in conventional way. It is transformed the imaging agents and diagnostic tools with enhanced precision, potentially revolutionizing healthcare. So nanomedicines, it's a great outcome of this field, nanotechnology. Then nanoelectronics, nanoscale electronic devices, they are pushing the boundaries of miniaturization, allowing for faster and more efficient computing and communication technologies. The last point I'll be talking about is the social implications of nanotechnology. While nanotechnology holds great promise, it also raises ethical, safety, and regulatory concerns that need to be addressed to ensure responsible development and deployment. And finally, I would like to say that this nanotechnology, it's a cutting edge technology that explores the unique properties of materials at the nanoscale, leading to revolutionary advances in various domains. Its interdisciplinary nature and potential for transformative applications make it a key area of scientific research and technological innovations. So these were the 10 important points that I wanted to talk about, about the